Hello everyone and welcome back. So let's solve more problems from improper integrals. Now let's start with an easy problem. So the function is 1 over square root x. This function is discontinuous when x is equal to 0, and you can see 0 is the lower limit of the integral. So we are going to rewrite, this is an improper integral, type 2 improper integral. So we are going to rewrite this integral as limit. Okay, first let's replace 0 by a letter, let's say it's t, and 1 over square root of x limit, and t get closer to 0 from which side? From right hand side of 0, right? Okay, so how are we going to integrate this function? So we know square root means the power of half, right? So I can write this function as x to the half, 1 over x to the half. Now to help with the I flipped the limits, right? It's from t to 1. Okay, now to help with the integration, I'm going to take this x to the half to the numerator, and I'm going to write it as x to the negative half. Nice. Now from here on, the integration is easy. Limit t goes to 0 from the right. When you integrate x to the negative half, you get x to the negative half plus 1 divided by negative half plus 1, and you are integrating, and you have to evaluate this result at t and 1. Okay, so let's see what we get. Limit, when t get closer to 0 from the right, negative half plus 1 is actually positive half, and you are dividing by positive half. Dividing by positive half is same as multiplying by the reciprocal of half, which is 2. And now you have to evaluate the function at 1 and t. So let's do the evaluation. T get closer to 0 from the right, so it's 2. You evaluate x at 1, so 1 to the half minus 2 evaluate x at t, so t to the half. All right. So 1 to the half is actually 1. 1 times 2 is 2. So limit when t goes to 0 from the right, so 2 minus 2t to the half. Now let's take the limit. When t get closer to 0, this term is actually getting closer to 0, right? You are taking each time you are taking a square root of a small number. Okay, so the number is getting smaller and smaller, so it goes to 0. So the limit is 0 for this part. So limit of 2 is 2. So 2 minus 0 is actually the limit is 2. 2 is a finite real number. So because of that, this integral is going to be a convergent integral. Great. Okay, so let's look at the second example. All right, here's my second example. You have to integrate natural log x with respect to x from 0 to 1. But the problem with the function natural log x is that it's undefined when x is equal to 0, or there's a vertical asymptote at x is equal to 0. So the function is discontinuous at x is equal to 0. Okay, if you're not sure, just draw the graph of ln x. Okay, right, and 0 is actually the lower limit of the integral, which means this is a type 2 improper integral. So we can replace 0 by a letter t, and we have to integrate ln x with respect to x, and we can say limit when t approaches to 0 from the right hand side, right? Okay, great. Now this problem is little bit different because integrating ln x is not straightforward. To integrate ln x, we need integration by parts. So if you are going to use integration by parts, you have to choose u and dv. Right. So what's your u going to be here in this problem? Well, we can use LIAT rule. Okay. So the logarithmic functions gets the priority. So ln x is actually will be u. Then what's dv? dv is going to be everything else, which is dx. Now from u we can take the derivative of u with respect to x, which is going to be 1 over x. That means du is actually 1 over x dx. Great. And we have to find v. So if you integrate 1 with respect to x, it's going to give you x. So that's your v. All right. So now then we just need to use the integration by parts formula. So the integration by parts formula is, if you have to integrate u dv, you're going to get a uv minus v du, right? Okay. So let's use that. Let's do that here. Limit, don't drop the limit, limit when t goes to 0 from the right, Okay, so this integral is now going to be u times v. So u is ln x, v is x. So let's write x in front of ln x minus, now you're integrating from t to 1, okay, and it's v times du. So x times du is 1 over x dx. So here x cancel out, let's close the brackets. So what we have is limit when t get closer to 0 from the right, okay, you have x ln x. Now you have to evaluate this at t and 1, okay. I almost forget that. So t and 1 minus, let's put the limit here also. Now it's kind of like I expanded these brackets, okay. So limit when t get closer to 0 from the right. Now you still have to integrate what x when x cancel out with x. So you just need to integrate 1, right. Okay, so that shouldn't be hard. Now let's write this limit when t get closer to 0 from the right, it's x ln x. You evaluate it at t and 1. Now take the limit again, okay, and if you integrate 1, you're going to get x. So you have to evaluate x at t and 1. Great. So let's evaluate this function. So limit when t get closer to 0. First evaluate this at 1. So 1 x is 1, ln 1 is actually 0. So what you have in the beginning is 0 minus, now you substitute t for x. So it's t ln t, okay, minus limit when t get closer to 0 from the right. So substitute 1 for x. So it's 1 minus substitute t for x. So this is what we get when we substitute 1 and t for x. All right, great. So let's simplify this furthermore. Limit when t get closer to 0 from the right, 0 minus t ln t is minus t ln t, minus limit when t get closer to 0 from the right, it's actually, well, here we cannot simplify furthermore, it's just 1 minus t. Right, now let's find the limit. So let's look at the second term, okay, because this term is a little bit tricky. So when t get closer to 0, this t, it's getting closer to 0. So the limit of the second part, 1 minus 0 is 1. So it's minus 1 from here, right. But what's the limit of the function negative t times ln t when t get closer to 0? Think about this. When t get closer to 0, this t is getting closer to 0. ln t, well, it's getting closer to negative infinity. Now this is an indeterminate form, okay. You cannot multiply 0 by negative infinity, that's undefined, okay. Now why ln t goes to negative infinity? If you remember the graph of natural log, okay, this is how it looks like, okay. I'm not the best artist, but I will do my best. There's a vertical asymptote at x is equal to 0. So when t get closer to 0 from the right, the function goes to negative infinity. Okay, so how are you going to find the limit if you have an indeterminate form here? Well, we can use L'Hopital's rule. So let me show you. So limit when t get closer to 0 from the right, okay, so let's write it in a nicer way. I can write here, let's keep that minus there. I can write this as ln t dividing by 1 over t. Okay, so this t, I can write it as division of 1 over t, which is the same thing. Now if you are dividing by 1 over t, it's same as multiplying by the reciprocal of 1 over t, which is t. Okay, it's a math trick. Now here the limit of the second part is negative 1, so we can probably keep that negative 1 separate from there. Okay. Now we can use the L'Hopital's rule, okay, because L'Hopital rules means differentiate the numerator. So derivative of ln t is actually 1 over t, okay. Derivative of 1 over t is negative 1 over t square, okay. So remember, to differentiate 1 over t, you have to write it as t to the negative 1. If you differentiate t to the negative 1 comes out, negative 1 minus 1, t to the negative t 2, that means it's negative 1 over t square, okay. So that's what I wrote here, right. We use the L'Hopital's rule, okay, minus 1. So let's see what we get here. Let's try to simplify this. So it's negative 1 over t, and dividing by negative 1 over t square is same as multiplying by negative t square. right? Just multiplying by the reciprocal of 1 over t square. So, t cancel out, this minus 1 stays there. So, limit when t get closer to 0, negative negative plus, so it's plus t, right? Okay, so what do we get? Because t cancel out, t left in the numerator. So, when t get closer to 0, this t is getting closer to 0. So, the limit of this part is 0. 0 minus 1 is minus 1. So, the limit is minus 1, limit is finite. So, again this integral is a convergent integral. Now, it look like a very simple integral, right, integrating ln x, but tricky thing is to integrate ln x we needed integration by parts, but not only integration by parts, we needed L'Hopital's rule to find the limit of the final function. Okay, so there are several things to refresh or learn in this example. Okay, I'll see you in another example. Right, here's my third example. Now, the function 1 over square root 3 minus x is discontinuous when x is equal to 3, and that bad point is the upper limit, upper bound of the integral. So, this is a type 2 improper integral. What do we do here? Well, replace that 3 by a letter, and we are integrating 1 over square root of 3 minus x with respect to x, and let the limit t goes to 3 from the left hand side. Right. Okay. So, now it's just we need to perform the integration. Right. So, how do we integrate 1 over square root 3 minus x? So, there are several ways. There's an easy way and there's a harder way. What I would do is I would use integration by substitution. Okay. So, what I'm going to do is I'm going to use integration by substitution, and my substitute is going to be 3 minus x, not square root 3 minus x, just 3 minus x, because then when u is 3 minus x, du over dx is going to be minus 1. So, that means dx is going to be minus du. Okay. Let's see what we get. So, if you substitute, what we get is limit when t get closer to 3 from the left, it's going to be 1 over square root u, and dx is minus du. So, it's minus du. Now, the limits of the integral has to change. So, when x is equal to 1, u is going to be 3 minus 1 is 2. When x is equal to t, u is going to be 3 minus t. All right. So, this is going to be limit when t get closer to 3 from the left. You are integrating from 2 to 3 minus t, integrating negative 1 over square root 2. So, square root u. So, square root of u is u to the half. So, it's on the denominator. I am going to take it to the numerator, so that my integration becomes nice. So, it's minus u to the negative half, right? Okay. So, let's see what we got. We can now, so let's write the limit part first. Now, if you integrate negative u to the negative half, it's going to be negative u to the negative half plus 1 divided by negative half plus 1, right, and you have to evaluate it at 3 minus t and 2. So, let's do that. Limit when t get closer to 3 from the left. So, it's minus u to the half divided by half, and you evaluated it at 2 and 3 minus t. Now, dividing by half is same as multiplying by 2. So, we can have it there, right. So, let's do the evaluation. So, if you evaluate this function minus 2, first evaluate u at 3 minus t. So, it's 3 minus t to the half, okay, minus 2. Now, you substitute 2 for u. So, it's 2 to the half. Okay. So, what do we get? So, limit of t get closer to 3 from the left, it's minus 2, 3 minus t to the half, minus minus plus 2 times square root 2, right, because 2 to the power half is square root 2. All right. So, what's the limit? Well, when t get closer to 3 from the left hand side, okay, this is going to get smaller, right. 3 minus a number extremely close to 3 is getting, the difference is getting smaller and smaller, right. So, this approaches to 0. So, the limit is going to be actually 0 times negative 2 is 0, 0 plus 2 times square root 2 is 2 times square root 2, and again the limit is finite, and hence this is a convergent integral again. Okay. So, those are my 3 examples. I will do more examples in the next video. I mean, I guess I have to do an example of a divergent integral as well. We only had convergent integrals in this video. So I'll see you in the next video. Thank you very much.